everybody. Today we're going to work on page 5 of the blue folder, which is talking about domain and range. So let's just get started real quick and go ahead at the bottom and let's call a little table underneath here. That's why we left this little space. We're going to make an XY table, and we're just going to remember Dora the Explorer. Okay? And so you can do this the second you get your star chart. If you want to, just write this down, XY Dora, and that way when you get to domain and range, you can remember that X represents the domain and Y represents the range. Okay? Easy little trick to help you along. Alright, we're going to start right here with domain and range, and we're going to open it up. The domain of the function is, and we just said the domain of the function is the set of all X values. Domain is just the set of all X values. And range is just the same thing, but the set of all Y values. Okay? So domain is the set of all X, and range is the set of all Y. Dora. Domain, X, range. Okay? So let's open it up to the inside here and look at this little brochure looking thing. And we have to decide about discrete or continuous. So discrete means that it's not connected, and continuous means that it continues on and on. It's connected with dots. Okay, so this graph is discrete because it has dots, which I really mean are points. So it has dots only. Okay? And this graph is continuous because it has a line. So continuous because the points are connected. Okay? Alright, how would we represent the domain and range here? Well, we would represent it using a list of numbers. And so we would say X and Y, and we would say X equals, and then we would do the little bracket or braces thingy that we talked about, and we would say numbers. Okay? How would we represent domain here? We would use inequality symbols, like Y is less than or equal to, or X is in between two numbers. Okay? So if it's discrete, we're going to write a list, and if it's continuous, we're going to use these inequalities to represent that. Okay? Alright, so I didn't want to do these because we're going to do them up in this other foldable. I just wanted to make sure you had, this is kind of a vocabulary list right here. What is domain and range, and what is discrete and continuous? And continuous. Okay, so that's what this is all about. How do we do it if it's discrete, and how do we do it if it's continuous? Okay, so let's move up to this foldable up here at the top. Now the whole foldable is actually done sideways. So when you're writing in it, you're going to need to turn it sideways, and we can write in it sideways like this. Okay? Be sure that when you can fold this graph right here, that you can see the whole graph where the y-axis is and everything, and that it didn't get cut off. Okay? I remember last year we had a little bit of trouble with that. Okay, so we've got two different kinds of graphs here. We've got a, what kind of graph is this? Discrete, because it has dots, and we have a continuous graph at the bottom. So let's talk about how we're going to solve for domain and range if we have dots. What do we do? Well, we have to list the domain and range using points from the graph. Okay? So over here, you can come to your graph and write the points out. So this is going to be very difficult to see. I'm going to make this X and Y axis better highlighted with the yellow. There's the Y, and there's the X. Okay, so this first point is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 0, 12. The second point is 2 down from 12, so 1, 2, 3, 10. The third point is 4, 5, 6, and then it's going down from 10, so 9, 8. The next point is 7, 8, so this was 9, comma 6. The next one is 10, 11, 12, comma, go down 1, 2. No, 4. And then this one's going to be 13, 14, 15, comma 2. And then the last one is 19, comma 0. Make sure I got those right. Oh wait, no, 18, comma 0, sorry. It looks like it's on the 19, but I think 19's at the very end. So 18, comma 0. Okay, so here's my list of all of my points. So to do the domain, I'm just going to say x equals, and then I'm just going to go list all the first numbers in all the ordered pairs. So 0, comma 3, comma 6, 9, 12, 15, and 18. Okay? And then my range is going to be y equals, and you do the same thing, but this time you list all of the numbers that are second in the ordered pair. 12, oh, and we want to go in order from least to greatest, so we're going to start over here. 0, 2, 4, 6, 8, 10, 12. And you're done. So domain and range is super easy. All you do is list them from least to greatest. Okay, looking at this graph here, it is continuous because it has a line. Continuous. Okay, so make sure I spelled that right. Okay, so continuous because it has a line. So for domain and range, we're going to go ahead and list it using inequalities. So remember, this is where you draw your borders, your sides of your graph. So this starts here and here. And honestly, I'm having a hard time seeing the x and y axis, so I'm going to highlight that yellow real quick. Okay, so on the x, it's between 1, 2, 3, and so negative 3. So x is going to be between two things. So I went ahead and put it in between the two symbols, like this, and then I wrote my negative 3. And then the biggest x can be is 10. And now we need to look at our dots. So remember, an open dot means not equal to. So we're going to use less than or greater than. And remember, a closed dot, so we're going to say this one stays just like it is. But this one is a closed dot, and a closed dot means equals to, or less than or equal to, or greater than or equal to. Okay? So here, it's at the end, so we need to say or equals to. Alright? For range, we're going to say, well, we're in between 2 on the range as well. So I draw my top and my bottom. Make sure when you draw it that it goes through the, it's a pretty straight line. Don't do like I did and get all crooked. That didn't help me any. Okay, so range is in between 2 because there are no arrows. So we're going to put y in between the two of them. And then it's the lowest it can be is negative 1, 2, 3. And the highest it can be is at 1, 2, 3, 4, 5. Is it 5 or 6? 1, 2, 3, 4, 5. Oh. Well, or 6, wherever you see it. This is a really badly drawn graph, but I think it is closer to 6. And since that's a closed dot, it gets a line underneath it, and that's an open dot, so it stays just the same as it is. Okay? So that's domain and range, discrete versus continuous. The rest of these won't take nearly as long. Alright, so let's talk about domain and range from a table. So from domain and range from a table, we're going to have to list the ordered pairs. because if I have a table, it's discrete, right? So I'm just going to do this one. We won't do both of them. So domain is going to be blue. So we say x equals squiggly line, -3, 0, 3, 6, and 9. And then we say y equals, remember f of x is just a fancy way of saying y, so that's my domain. So that's my range. So y equals, and then we just go in order, 2, 4, 6, 8, 10. Okay, easy enough. Alright, and if I have a mapping diagram, same thing. It's the exact same thing as a table. Okay, so we just pretend it is a table. So pretend it's a table. And list the domain. Okay, so domain and range. Remember, if I'm going too fast at any time during this video, make sure you pause it so you can pay attention and write down the details. Okay, so domain is going to be this first one. This is x, right? So x equals squiggly line, -3, -2, 1, 3, and 4. And then this is my range. This is y. And in my range this time, I only have one answer. So I say y equals, and I don't have to put my squiggly line because there's only one number that y could possibly be. So my range is 3. Okay. Alright, so for verbal, so if we have a verbal description, it's a little bit harder to find the domain and range. We have to think a little bit harder about this. Okay, so sometimes we have to look for the rate, sometimes we have to look for just whatever it is. So we have to figure out what does x stand for and what does y stand for. Probably the easiest way to do that is to find the rate. So it says a 10,000 gallon swimming pool is being drained at a rate of 750 gallons per hour. So remember when we talked about interpreting rates, it's change in y over change in x. So it says 750 gallons per hour. That's 750 gallons per 1 hour. So that must mean that my domain is going to be hours. And so that means I need to decide, what can my domain be in this case? Well, I can't be less than 0 because that's negative hours. So I know x has to be between two numbers. Okay, so 0 is my smallest. It could be equal to 0 because I could have 0 hours. Now, let's talk about how much time it's going to take to drain the pool. So to do that, you're going to divide 750 divided by, you're going to divide 10,000 divided by 750, and you get 13.3 repeating. So that tells me how many hours it's going to take to finish draining the pool. So that's going to be the other half of my domain. Okay? And it could be equal to that time because it takes that long to actually drain it. Alright, and now let's talk about the range. So the range we said was my gallons. And so we have to think about what is the most gallons I can have and what is the least gallons I can have. So the most number of gallons I can have is 10,000, and the least number of gallons I can have is 0. That's the most gallons, and that's the least gallons. Okay, and we won't worry about this one. Alright, so if they give you a verbal description, you have to kind of decide what is x, what is y, and then you have to decide what is the most x can be and what is the least that x can be. And what is the most that y can be and what is the least that y can be. So this, if you label them with the words, that might help you figure out the domain and the range. Okay? Alright, these last two on here don't have anything to do with domain and range, but we did have to find a place to put them, and they fit really nicely on this page. They talk about Hoy and Vux, so we're just going to go real quick through Hoy and Vux. So this one is going to be Vux because it's vertical. So put Vux there, and we're just going to open these flaps, and we're going to say the V stands for the fact that it is a vertical line. Remember, vertical goes up and down. The U stands for the fact that the slope is undefined. Remember when Slope Dude fell off the cliff, he died and yelled undefined. And the X stands for the fact that we would write an equation as X equals something, and it's where it crosses, not where it crosses, but it crosses the x-axis. That's what we need to write. The line crosses the x-axis. Okay? So, I just want to show a quick example over here. If I had this graph, and I drew it with 4 little tally marks that way, and I drew a vertical line right here, it's x, the equation for this would be x equals -4, because it's crossing the x-axis at -4. Okay? So that's the Vux. We're going to do the same thing for Hoy real quick. So go ahead on the outside and put Hoy, H-O, and Y. And Hoy, the H stands for horizontal line. Remember, that means it goes left and right. That means that the slope is 0. And then the Y stands for equation. Is going to be y equals something, and it crosses the y-axis. Okay? So if I had this equation with a line going through the -4, we would say that this is y equals -4 because it crosses the y-axis at -4 and it is a horizontal line. Okay? Alright, thanks so much for watching. Have a wonderful day.